Hey everyone, welcome back to Fully Defined. My name's Chris. This is the LEGO by SolidWorks Build and Learn series where we're recreating the Volvo wheel loader. In this episode number 7, we are doing a very small part called the hinge cylinder. This is the one that connects some of the lift arms and the gear mechanism for the front to the digger bucket. It's a very small and intricate part and it's quite hard to measure. And it does have some interesting sort of draft angles and curves to it. So quite a bit to learn from this video. You'll see it's one where I don't have the perfect approach to start, but you see me troubleshoot and work through the part as we go. Also encountered a SolidWorks crash, so that was fun. And you can see how I deal with that there. So yeah, let's get into it.
This black hinge cylinder. This part has a axle hole on the end. Very small detail around like this section in the middle. There's an axle hole on the other side. Can't see it here. Quite intricate little details. Let's get into it. Start on the top plane. Do the outside of the part, which measures at 7 millimeters. Yeah, I'm going to extrude that up to this section here, around 9.6. Line 9.6. And now I can't see how deep it is. Caliper inside. There's quite a way through 10 millimeters. So the depth actually goes like further than this section, or it's exactly the same all the way up. I suspect that's it, because what we get with this part is there's this axle and comes in and that goes deep. If I see how far it goes, it's something like that. It's going up quite a bit. So let's create that inner detail. Usual sort of thicknesses for the axles. Feels quite loose. So by usual detail, I mean it's like 4.9, and then we've got that corner detail like that. That over there. Let's do a circular pattern, something like that. Extrude cut that all the way through, and we might tweak a bit more later. Planes there. All right. On the outside, there's a couple of channels, kind of give it an appearance of in-out. You can roughly see them there. There's like steps. So I'm just going to measure the diameter of those and put those in, and we'll do that on like with a revolve cut. So diameter of one of those sections comes down to 6.5, let's say 6.6. So what I'm going to do is put a little section like that, and 6. You see it's quite a small difference. And then the thickness at the top, 1.1 millimeter, and the thickness in between, very small. So that's the same. And then we have 1, 2, 3 of those, and the total section is 7.8 millimeters. So if I put a line here, so that is 7.8. I'm going to grab this section, do a linear sketch pattern going up. Now I want 3 of these. I don't add a dimension. What that lets me do is use this construction line as the dimension for where that position is. And then I can do a revolve cut revolve, increase that detail for us. And then I can keep going with the model. Oh, that's pretty neat. Now, what else do we have? So we've got this face, this that extends up the top. This bit is all the way up high, and that it's a flat face. Hard to see. Again, camera detail is not picking it up. That's a flat face across the top. Your camera coming for the next stream, definitely. Flat face there. The full height of this. And on the very top face, it's got a curve. So that face, it's got a curve. Measure the height. Get to 19.2. What we might do for this bit is just roll back in our model. And so just roll up to here. Going to go on the front plane, get a sketch that's going to sit a little bit inside that. You're going to roughly measure that. 6.8. How does that work? So the diameter, 7, might be a little bit under. But midpoint of that to there, vertical. Those two equal. Height of the whole thing was 19.2. I'm going to say that it's got an arc here. That arc's pretty small. So let's say that arc is only, I'd say, 0.5 millimeter. And we can go from that bottom face up to the top. Alt Shift 19.2. And then measure some of those corners where it is at the very top, 5.2. Okay, that's a shape. Not bad. The width of the part, width of the feature, 3.2 millimeters. And I just want to make sure it stays inside the diameter here, and it's not quite. I wonder if there is a bit of a curve to that part. It's so small, right? Like it can't quite zoom into enough detail. I need a microscope camera. Maybe it does have a bit of a curve to it, which I can put in. So if we left it like this and then did a sketch on this plane, see how we could do this. Should we use this edge? Yeah, why not? Sketch like this, extrude cut, through all, flip side. That's one way of doing it. It's not the neatest. It doesn't really give me the curve on this face. Like if I delete this face, it's going to straighten it right out. That's not what I want either. What I probably want is that. Yeah, I want that. I want to work out what that draft angle is to get that face. That is a 5-degree angle. All right, so this is what's going to help me. I'm going to change these to be vertical. Right, 20. I'm going to completely change this part. So we will extrude it up in a different way. I'm going to convert that edge. I'm going to draw a straight line across either side. Dimension between. Cut that off, extrude up. Can I do it the way I want to? We'll see. When I come up to here, I don't want to merge it. That's the important part. Then I'm going to do a thing using contours. I'm going to select that sketch, select this contour. I'm going to go up to surface on both sides. I'm going to merge with this top face. I'm going to delete a couple of faces. So this is a bit quick and nasty, but it works. That one doesn't work. I have to do it in 2 separate steps to get those little edges off. And then I know that it was a 5-degree angle. So I'm going to add draft. Oh dear. I moved too fast. Frustrating. Didn't even save it. Can you believe it? Yeah. And really, really, really annoying that. Lucky annoying. Okay. Let's just get back to where we were pretty quick. 7.2, 4.9. See what my memory's like. 1.9. Extruding up. How did I want to go? 9.6. Let's save this part before we do anything else. In cylinder 1x2, looking. Hugo, top part with a revolve, an extrude cut, or is the shape you're looking for different? You could do revolve and extrude cut. Yeah. Yeah, there's definitely a way of doing it. Why don't I do it that way this time around? I'll show you how. I'm sure you probably know, but I'll give it a go. Let me just get back up to that point first. After my crude SolidWorks crash, 1.1. What was this bit? 6.6. That was 1.1. And no, 3 of these driven by that revolve cut around here. All right, so let's do a revolve this time. You know what? I think it's a pretty good idea, except the top curve, because the face on the top is not revolved, like it's extruded. So I can do revolve. That's what you can't do. Like if the outside is revolved, then it would work. But yeah, I actually can't. I don't think I can do a revolve for this. It's not the right geometry. The reason I say that, and I apologize that the camera detail is not going to pick it up maybe enough, but this face here, see this one that's kind of got that gloss on it right there. It's got a little bit of curve to it, but it's not circular like everything else. It's quite flat. Right? I can tell that the lighting doesn't match up from face to face. So this bit is circular. This bit is a lot more flat. That's why it's different, and why you got to model them separately, 2 different steps. That's why I was doing a extrude up, and then I was going to draft it, because then my extrude up can have some curve, but the draft is just going to bring it in a little bit. Hopefully I'll be able to explain that as this bit gets done. Let's do it now. So what I was planning on doing was, all right, this 3.2 and extrude that bit up. Now I didn't do this correctly before, but the total height is like 19.4, and that's from the ground. So put that in, but put in offset from surface, and you know, this face, change, and there's my shape. Now I uncheck merge. Yeah, that's right. Here you go. 5-degree angle, draft, hit that face and that face. Okay. So it's not even this. I'm not sure if this is right. Like it's close. It's circular there, but is that bit circular? Yeah, it is 2.74. But if I did a revolve, I'm not going to get this line here, I don't think. But like the detail is so small, doing it your method, that would probably work as well. And you'd be hard pressed to notice the difference. What I didn't do on this one was that curved top, but I'll just do that slightly differently now, because there's a few details on this side that I need to put in. So if I look at the front view, I'm not sure if this is going to work out the way that I wanted it to now. See, from that edge to there, 0.5, that and that equal. That 1, extrude cut through all, that's okay. And then there's this kind of raised detail here. It's actually probably better showing in this image. You see this kind of raised section here. I need to put that in. See this one, when you zoom in, it looks more flat across that edge. Helps a little bit. Yeah, it looks a lot, I don't know, looks kind of curved, kind of straight. You know, we compare, not quite there yet. So the other detail I needed to put in was across the middle. That's on this section where I need to convert that edge. I need to have a straight face across from one side to the other. At the bottom, I'll do it from the bottom, 2.5. And then height, I think I've already done the height, 9.8, 9.6. Yeah, how do I do this? Kind of done this slightly the wrong way around. I also think just going to check I've got that correct. Don't think I do. That's 7.8, but it's got another gap on the top of 1.1. Yeah, so that shouldn't be there. These are separate. So that is 1.1, and then that is 7.8. It's going to look better now. Okay. Sometimes you've got to go backwards a little bit, just up and down the tree to get things right. That's an example here where I knew this. That top face now needs to come down. It's actually this sketch. Let me bring that up, because now this one actually needs to come down up to this vertex, flip sides, cut. And this really weird kind of looking shape. And that's because I said that this was 10 millimeters deep, but I don't think it is. When we put that on, that actually needs to start on this face like that. And this top section needs to be closed. Yeah, a little bit messy. This not the most efficient way of doing it. Let's convert these. Let's delete that. Let's delete those. Bring that down. Trim that away. Let's extrude this a millimeter. Let's join them all together now. Okay. And then I can do that angle and cut. So you see it's got like that kind of angle. It's quite severe. The top of it, it's about 1.8 millimeters. At the moment, it is 2.5. Best way to do this, let's see if we can draft that through all these edges at once. That's about right. That is looking much better. Totally out of order, this one, but that's okay. Front plane, just save. Now it's got that little divot, that little cut there. Not sure if it's actually used for anything. It's tiny. I'm not even sure if it's that. But we can say, we're going to go from this face through all, or we just go sketch plane through all both, but we put it above this. Yeah, we put it here. We want to extrude that. Just trying to work out the most efficient way of doing it. This isn't it. Surface through all. And this isn't it because I have to do 2 separate features to get it to work. It's not quite that big. All right, nearly there. That chamfer hole detail looks a lot like a revolve cut. So we go to this view and we're on the right plane. We are doing a cut like this where it's going to have a flat face and then an angle that comes out like this. And it's going to be near impossible to measure those 2 points. The best I can do is maybe measure the diameter of the hole on the outside or on the inside. Do both. And it's like 1.8 on the middle. It's 1.8. And on the outside face, 3.2. I don't know the depth, and the height from the top, we can eyeball 2.8. Just turn off the section view for a second, then I can get that edge and the depth. Let's just do something like this, because what we're going to do is mirror that sketch and then do a revolve cut around, last detail is there's that kind of cut on the top. They've got here this angled section. That's because another part sort of fits onto this. Which one? But this is where it helps sometimes to understand how the parts go together. It can help you. So this and this go together, so it kind of pushes on, and it's got a slight ratcheting interference, so it will hold position. Cool. So you do that slot. That looks like a mid-plane cut extrude. So back to this section here, but separate to the revolve cut that we just did. We will once again do a sketch because we'll mirror it. But this time, grab that edge, very much like this. We can measure the top, just how small it is in the middle, 2.8. The angle does not need to be that great at all. Let's drop the angle down to that midpoint there. And last step is how far does that cut go across? Most of the way. And that's angled. It's like good draft out. See how it looks, 3.2. mid-plane. That looks pretty good. What would I change on this? Maybe it's got to be more, but it's got a bit of draft. Top plane, this edge, and this edge going like that. That's actually much more accurate, and perhaps that is a little bit less. Now, something looks really weird on this. Definitely doesn't look like my dimensions are right. Let's just go through those and check. I'm off by maybe 5 millimeters somewhere, I think. Yeah, it's 14.4, not 19. This one, yeah, 14.4. That looks a lot better. That's even smaller. That's not quite right. What happened there? That is not the mid-plane. That part is looking much, much better. Need to fix up that internal section. What's the depth of that now? That is 7.8. How did that get there? This bit. Let's just go back to the very first contour, do an extrude cut, select the inner face, and just go up to surface. And that will do. Very nice. This part is black. Let me just update the name. A material. Put it into our group with everything else, and that is another one. Done. Hey, thanks for watching all the way to the end. Really appreciate that. This has been the LEGO Build and Learn series by Fully Defined. If the next video has been released, it'll be on the top link to your right. Please hit the thumbs up and subscribe, and leave a comment below with what you'd like to see next. Your feedback is what motivates me to provide more content. See you in the next one.